my name is Jimmy Yang. Today I will talk about delta Cm, locus of elliptic curves. That is, there is an order we call OCM. Order O acts on a series of elliptic curves such that the endomorphism ring is isomorphic to the order O, and the discriminant of the O of this order is called delta. This is the delta Cm locus of elliptic curves. That is, there are a series of elliptic curves such that they have the same order, or we can say they have the same delta Cm. So you can view it as an orbit. There is an orbit. There is an action acting on one elliptic curve, and from one elliptic curve to another elliptic curve, but the delta Cm does not change. Okay, I read the article to you. This is the article authored by Pete Clark. An elliptic curve over a field of characteristic 0 has complex multiplication if its geometric endomorphism ring is an order, that is O, is an order in an imaginary quadratic field. Imaginary quadratic orders are classified up to isomorphism by their discriminant. So there is a one-to-one correspondence between order and the discriminant delta. Each discriminant is a negative integer congruent to 0 or 1 mod 4. Each negative integer delta is 0 or 1 mod 4 is the discriminant of a unique imaginary quadratic order, and for each imaginary quadratic discriminant delta there is a unique close point, J delta. So a unique close point, J delta, it can be viewed as an orbit. So a close point corresponds to an orbit. So we symbolize it as J delta, which is belong to x1, which is belong to x of 1, defined over Q. So x of 1 is a symbol of modular curve. So J delta is belong to x of 1, corresponding to elliptic curves with Cm by the order of discriminant delta. Thus, for any modular curve S of h, defined over Q, where h is a subgroup of a general linear group of dimension 2. So thus, for any modular curve x of h defined over Q, we have the delta Cm locus, which is the fiber of the map pi from x of h to x of 1. So pi can be viewed as a restriction map, or we can view it as a projection. So from h to 1, so x of h to x of 1 is a map, and we pull back from x of 1 and view all of the fiber. So there is we view the fiber as the delta Cm locus. So delta Cm locus can be viewed as a pullback from x of 1. So we have the delta Cm locus, which is the fiber of the map pi from x of h to x of 1 over the closed point J delta. So each J delta corresponds to a delta Cm locus. This is a finite spectrum of Q of J delta scheme, and it is etail if discriminant is less than -4. A recent result of Clark nearly determines the delta CM locus on S of n defined over Q, where n is a natural number. So if we consider a series of elliptic curves and we only consider their n torsion point, so we restrict it to the points. The order of the points are n. So this can be viewed as x of n from the interpretation of modular curve. So a recent result of Bourdon and Clark nearly determines the delta CM locus on S of n defined over Q. And I will talk about this CM ring next time. Bye bye.